Alright, it looks like we're live. Very good. Alright. We're live on Kick and YouTube, by the way. I know that I never say that, but it remains true. Alright, I already got the Kick chat popped out. Let me get the YouTube chat. Notification is sent. Very good. Okay. Minimize Discord. Don't get distracted. Cool. Yeah, I do this stupid thing where, like, I'm in a bunch of Discord channels, but I, like, never talk in any of them. I just kind of lurk. And so I'll just, like, whenever I open Discord, I like, compulsively go and check all the random Discord channels. There's never, like, nobody's ever talking about anything interesting. Which is a horrible thing to say. Like, wow, dude, really? Like 30,000 people are having conversations and you don't think any of them are interesting? That's not a good sign. That's terribly antisocial of you. Yeah. Actually, the most interesting stuff that I've ever read has been people working on like difficulty calculation kind of stuff. That I would actually read. But most of it is like, it's not necessarily low information density. It's just like I haven't been following the conversation, so it's like I get just like a vague impression about what they're talking about, and it's like I can tell something interesting is happening, but also I can't like jump in there and be like, hey, what do you mean by this? Can you explain that to me? Yeah, I don't know. Huh. Also, part of it is like, with that kind of stuff, like, although I'm interested in it, I also like want to work it out for myself and sort of keep the knowledge for myself as well, because I'm trying to make a game with it, which something seems wrong about that perspective too, but I'm just not sure. Yeah, something's wrong with that. Something's wrong with it. Well, on a one-on-one basis with people that are actually interested in like difficulty calculation kind of stuff, I will absolutely like go to some degree of depth, assuming that they're able to follow it, or like it's relevant to their current understanding. I'll absolutely talk to them about it for hours, but that's like that's very different from posting about it publicly, you know? Because when you're posting about it publicly, yeah, something about posting things publicly is just implicitly saying, like, oh, yeah, I don't care about any of these ideas or this information. It has no value to me. That's why I'm posting it publicly. Which is, I mean, that's really a terrible thing if that's how, if that were true for everyone, if that was like, if everyone believed that about discourse, it's like, oh, yeah, I post my bullshit on Twitter or like social media. Yeah, I don't know. The internet's gone to shit, really. I don't personally remember when it was ever good per se, but I know that what we have now seems kind of shit. Or maybe, maybe I'm just a shit person, right? Like maybe I'm the problem. That could certainly be true too. Just like, dude, I can't have relationships with people. That's it. I'm doomed. For each client, I will store a resizing array of the instant. This is not relevant anymore. This we're pretty much past this. I mean, I haven't actually implemented the resizing arrays, but we'll get there. We'll get there as soon as I figure out why my server keeps dying. It's giving me a seg fault, which is notoriously hard to debug. And honestly, not looking forward to this debugging at all. I think this is going to suck. I don't even think I'm going to figure it out all stream. I think I'm going to spend 45 minutes on it, get fed up with it, and just, like, try it again tomorrow. I think that's what's going to happen. But let's at least start with a simple reproduction. So, boop, boop, boop. If you remember from last time, we made a function which takes a player key event and will encode it in binary and send it off in a WebSocket frame. And I always eat just before the streams, so I'm always like burpy, and that sucks. 2 degrees. You're right. Yes, I remember this conversation I had with myself. Okay, and we're trying to get the spectator mode to work. And if we want to get the spectator mode to work, we first need some way of, in an automated way, sending sort of realistic key events, so just to make it easier for debugging, really. And it's a better test. Although there is an element of unrealism here too, I guess. But so basically, what I have here is not the connect button. The connect button doesn't do that. The autoplay button. If I click autoplay, what it does is it sets up a socket, it loads the audio file and step file, and then it will iterate all over, not all the notes in the file, but basically the first 300 notes in the file, because I don't want to send too many. I don't have resizing arrays implemented yet. And what it'll do is it'll just go ahead and send a key down and key up event to my server for each of those. And it just does it all at once. So basically, once everything's finished loading, boom, we send 600 frames worth of data. That's basically what happens here. I don't think there's anything wrong with that. Yeah, and that's why I was so puzzled why I got a seg fault, because this is 600 events, and the resizing array I have should be able to handle up to 1,000. Nevertheless, we will highlight from the update. No, thank you. Don't care. Okay, so I'm just going to go ahead and start my server. Oh, I already started my server. So I can go ahead and run this. And I expect to get a seg fault. Yep, it did its thing. We had this hilarious bug before where it just like kept sending the 600 things over and over again. That was fun. Okay. So that's fine. And OBS is doing that awesome thing again where it doesn't want to show me all the windows that I can choose from. Bro, please let me show my viewers what I'm looking at. It just now got a seg fault. Huh. Well, this is OBS is being a piece of shit right now, honestly. If I'm honest, I think OBS is being a piece of shit right now. Okay, from here it lets me pick it. Okay, now it'll let me pick it. It figured it out. OBS found it. Good job, OBS. God damn it. Piece of shit fucking awesome free software that I depend on for everything. Huh. That's peculiar. Yeah, that's peculiar too. See, I've just been writing off these random numbers as like irrelevant things. Don't need to care about them. But maybe I do. See, it's probably due to the fact that I haven't fully implemented the WebSocket protocol. Right, and that was going to be my next debugging step. So this is bad. This is I don't know what data this is. This is crap data. This is like reading, you know, random garbage that is in memory, I assume. Or it's reading masked data or something. Very odd. Very odd, this. And I don't know exactly what causes it, either. I mean, we get pretty deep into the list before we get a seg fault, right? But here's what we want to do. Okay, here's what we want to do. I would like to add some sort of extra checks. I guess I put it... Do I put it in here? Decoded message. Parse WebSocket frame header. Maybe we start here. Yeah, we probably start here. And we probably go ahead and pick out the WebSocket RFC, which is 60... 6455? That's right, yeah. I nailed it. I do remember it. Holy shit. Of course it's RFC 6455. Incidentally, by the way, I might have said this once before. RFC stands for Request for Comments, but I almost certainly looked this up on stream. Huh. Well, anyways, it stands for Request for Comments, but it's that an RFC is more like the final published document, so they're not requesting comments when they publish an RFC. Does that make sense? Well, it doesn't. It doesn't make any sense at all. Why would you call it a request for comments if you're not requesting comments? It's just tradition, supposedly, to call the final thing an RFC still. Literally, whoever they are, the Internet Engineering Task Force, they like throw up their hands and they're like, yeah, whatever. Every time I say throw up their hands, I think like they vomit their hands. They eat their hands and then they vomit them up. Yes, of course, that's what I'm talking about. See these guys. These are the ones throwing up their hands, you see? Mr. A. Melnikov. I bet he's like absurdly famous. Quantum machine learning. Oh, that sounds completely insane. Wow, he made a crap load of RFCs. Is quantum computing like crypto at this point, where it's like there is a small interesting core idea, but it's still too niche to be useful? Is that what quantum computing is? Is that where it's at right now? And there's like tons of people just making bank off of like over hyping and selling it. Quantum machine learning sounds completely insane. Quantum computing in and of itself doesn't seem that insane. Like I could believe that there's value in it, right? But there's we don't really have a big quantum computer. What we've simulated a few qubits or something like that. I don't get it. How can you do machine learning, and why do machine learning if it's not? I don't. The fact that like at least crypto has an actual finished product for all the years that it's been developing and doing stuff, right? Like it is a finished thing that works. People have bought things using crypto. Quite a few people use nothing but crypto to buy things. Like I'm not one of them. I haven't used crypto to buy anything even once, but what has quantum computing done for me lately? You know? I don't know. You can tell I really don't want to read this RFC again. Okay, I just want to know about the header. I don't care about the handshake. The handshake is working as far as I know. Yes, this. Finn. So, I should do something. This is completely insane. What is this statement? I should at least check that Finn is 1. Right? I should add some kind of check that's like, hey, if Finn is not 1, that's weird. Be aware of that. Is this a Boolean? It's a uint 8t. Why? Why do I do this to myself? Even better, actually. Hold on. Yeah, what's happening here? Huh. I guess that's an okay way to do it. It's just it just seems a bit iffy. Because, you know, I had that thing with a double, right? We had that whole thing about what happens if you don't use memcopy. But I don't know the equivalent of doing this. Well, anyways, I should do something like if header fin is not equal to 1, printf fin equals 0. Yeah, that's certainly weird, right? Now how about RSV? RSV 1, 2, and 3, 1 bit each, must be 0 unless an extension is negotiated. Don't know what that means. That defines meanings for non-zero values. If a non-zero value is received and none of the negotiated extensions defines the meaning of such a non-zero value, the receiving endpoint must fail the WebSocket connection. Why? Why, though? Is the federal government going to arrest me if I don't? Because I'm already not doing that. And so far, nobody's broken down my door. Give it time, I guess. See, and this is the interesting part, actually. That could be what's happening, right? Defines the interpretation of the payload data. If an unknown opcode is received, the receiving endpoint must fail the WebSocket connection. The following values are defined. Now, what's a continuation frame? Extension. The length of the application data is equal to the payload length minus the length of the extension data. That's another weird thing. If header RSV1 or this or this. And I probably do like this, just to make it a little bit more clear for myself. If any of those things, printf and RSV is non-zero. That's a huge problem. And then there's opcode. Now opcode, how do I test this? Oh, here. I typed this. %x0. You just mean 0, right? Do you not just mean 0? It's 4 bits. What's a continuation frame? What's a continuation frame? What's a WebSocket continuation frame? Why word it this way? This is so silly. No, you must not ignore continuation frames. If you don't implement them, then your WebSocket implementation will not conform to RFC 6455. Oh my god. And the government will kill your family. Continuation frames are fragmented WebSocket messages. All frames but the first are called continuation frames. All but the first and last are called non-final continuation frames. Okay. Isn't that what the lack of the fin bit for? Yeah, that's what I was thinking. Huh. Yep, that's a bit strange. Okay. So anyways, if header opcode is equal to 1, then we say that. So probably I would expect to see this message and this message. Hopefully I never see this message, right? And then all this stuff should just carry on working just fine, I guess. Yeah. And if it's a continuation frame that's causing me problems, then I can figure that out. Run C. Okay. And I'll go ahead and start up the thingy. Okay. Everything looks pretty uniform here so far. Aha! Right here. Oh god. And RSV is non-zero? What? What is this? What is this? What is this piece of data I was sent? $1024 from client 4. So this is the first run through. Somehow, even in the first run through, we got a quote unquote first int is negative 45. That I don't understand. There must be some other thing that's happening here. Because this shouldn't really happen. I'd like to be able to explain what's happening. I don't know how we have a non-zero RSV. I could understand a continuation frame. Right, that's pretty understandable. I mean, I guess I don't... It's possible that actually figuring this out doesn't matter because I'm going to improve how the client sends data in the future. But I'd like to understand what's happening here. What's the opcode for binary data? 2. We'll try it again. That's the only thing I can imagine is happening. Is it's like a control frame or something? I don't get it. It must be like non-encoded or something. It's very strange. Okay, connecting, sending data. What just happened there? Yeah, right here. What is that? What are you? What alien is sending me this message? Well, it continued processing. Well, there's many unexpected opcodes here. Holy cow. And we're still going. Okay. I guess this time we're going to get through all the data. Miraculously. Yeah, we made it. Okay. Yeah, that's very strange. We definitely got some junk data in there. Okay, we got opcode 10, opcode 7. I don't... First int is negative 64. I don't know what to do with this data. Like even the first time it happens, it's just so weird. I don't really get it. Huh. Well, I'm just gonna like discard any non-conforming header values or something. You know? You know. So what I should do... What happens at the end of this while true? I do need to do this. Right? I do kind of need to always do that. Payload length. This is a problem. Well, this is very strange. This is very strange because if it's if it's a non-conforming frame, if it has a weird header, then it could possibly give me some kind of erroneous value for the payload length. And what would happen in that case? Processed bytes. What's the purpose of processed bytes? Message pointer. What happens with message pointer? Message pointer plus equals frame bytes. Frame bytes is equal to header size plus payload length. Yes. This is exactly, yeah, that is exactly how you could get a segmentation fault. Yeah, that's exactly how you could get a segmentation fault, is if you if your frame is like not constructed validly and it tells you to read past your memory, read past the amount of data that you've even received and have in your in what I mean, in a sense it's a problem. It's my problem because I should have some kind of check to like message in, limit the position of the message pointer based off of received bytes, because received bytes can't lie to me. I mean, of course, I guess anything's possible, but I don't think it can lie to me. Huh. Yeah, so I need to... I mean, this whole while loop is kind of shitty anyways, isn't it? I don't like how I've constructed this while loop. Because I can't return prematurely the way it's constructed, and that's really frustrating to me. Because I, like, have to do this thing at the end. I could move this up somehow. I could do like a pre-check thing. Assuming that... Yeah, I think all the things that I use to control this while loop are sort of compartmentalized. Yeah, so if I brought this up, what would that let me do? I mean, I would obviously have to do the incrementation, like, here. Yeah. Processed bytes is equal to 0, received bytes is equal to that. So I could do something like while processed bytes is less than received bytes. And increment the message pointer. Yeah, because I will have copied what contents of the message I care about. Um, which might not in general be a good practice. I don't know. Seems like what I want to do. Yeah. So I don't, in theory, need that anymore. But this is a recipe for disaster right here. Yes. There should be a check here that's like, if what? What would I say here? Well, okay, so how does it actually happen? This is a little bit strange, isn't it? Cuz like this should sort of protect me, should it not? If frame bytes is some massive number. Could it be negative? It could maybe, like, yeah. But as a uint, right? I don't understand that. That doesn't quite make sense to me. Because even if we did say message pointer plus equal frame bytes, I shouldn't get a segmentation fault until I actually go try to access that memory. Unless header size is some gigantic number. Okay, so what parts are safe? This should be safe because it's just parsing according to the WebSocket RFC. Right, we're just copying data. Let me look at it again real quick. Okay, where could it be not safe? Well, this is just a header. Yeah. It's only gonna optionally read a few more bytes, which I guess could technically cause a segmentation fault if it's not even a WebSocket frame. Could totally be a problem. Seems like the less likely possibility. Huh. Huh. Interesting. Huh. And it could be a really tiny frame. I guess to make this work in general in like a completely safe way is kind of crap. It's kind of crap. Dang. Well, could say this. And if we're doing that, do we want to calculate, keep both numbers around? I guess we're doing that. So basically, I want to pass this into any of these methods that are reading memory. Oh, this feels so gross. Pass these into any of these methods that are reading memory, and use that to sort of help it avoid seg faults, I guess. Why did I write? That's not what it is. It's safe bytes left to read. Okay, so I will repeatedly have checks here. We assume that this is at least 1. We can assume safely that it's at least 1, because if it were 0, we wouldn't have gotten into the loop. Okay. So the second we access this, we're like, if this is less than 2, return. Give up. What did we return? Huh. Interesting. There's not a great concept of error handling. So I could return 1 for an error. Because we need to stop processing. That much is certain. And then here, and we're doing 2 and 3. Yeah. Right, so we need to be like, if safe bytes left to read is less than 4, return 1. And then here, we need to be 9, 10. Uh-oh. I is equal to 0. Frame data 2 plus payload extra bytes. Oh boy. Plus I. So this could be we definitely need some kind of check here, but I'm not sure what it is. Well, what's the max value of this, right? What's the max value of this? It's going to be plus 4, so I should put 6 plus payload. Shouldn't I put 7 though? Because generally my pattern has been... Yeah, I should put a 7. My pattern has been that this less than biggest number plus 1. That's the pattern. Okay. And then we need to check here. It's like if error code is equal to 1. Well, we could just be like not equal to 0. Break? We break the loop at that point. We simply break the loop at that point to avoid a segmentation fault. And then what will happen? I guess basically the server will just continue along its merry way and ignore the rest of the data that it received. Yeah, because presumably this receive action removes those bytes from whatever internal IO buffer is going on. Does it? Is my buffer size too small? Is that possible? That seems eminently possible, if I'm honest. Yeah, what's the deal with that? Is that... How does this work? How is this working exactly? First instance 1. Yeah. It could be that my buffer is too small. That could be another issue that's sort of holding me up. So what happens in that case? What would happen? That could explain something, right? Where I'm like, hey, I want to receive the message. Oh, the message is too big. What's receives behavior in that case? That's interesting to know. That's something I need to figure out. But for now, I actually like what we're doing here with the whole seg fault preventioning thing, and I would like to continue that process because this is generally good hardening to do for the code, anyways, in my opinion. So I'd like to continue that. Continue calculate frame header size from WebSocket frame header. So this should be safe. Because the worst thing that would happen here is that it's like a null value. That should be fine. We're not accessing any like bad memory. This is using message pointer again, so almost certainly this could get a seg fault. Let's see here. Frame data. Masked payload. Yeah, this is for sure potentially a problem. Yes, we want to assume that the client is trying to harm us. That's how you write good software. Just be as paranoid as possible in all your code. Just be like, does 1 equal 1? Or am I sure about that? Wait, let me double check. Is size of bool 1? Can I be sure about that? I actually don't know what the size of a boolean is. It could, for all I know, it could be more than 1. It could be 16 somehow. Oh, I have to do that thing. Wait, no, I don't have to do that thing. Because I break if that's the case. Yes, we don't have to do that thing. Okay. So if I just finish up here and pass this in, I will need to actually figure out how to modify this value correctly. But it seems pretty reasonable so far. Okay. So this is a char pointer. We set it equal to frame data plus header size. And we're going to be reading what? Well, we get the masking key. That's already in the header. That's safe. We're ORing it with masking key imod 4. That's totally safe. This is the part that's potentially not safe. So it's what is it? What is it equal to? So if we just start at frame data, that's 0. We have header size. That's where we're starting. So we kind of need a +1 in there, I think. And then we have payload length. Now I'm not totally sure about this. Crap. So let's think here. This actually might be safe. This might be exactly right because we never do exactly plus payload length. We're always -1 here. This might be fine. Yeah, because the max value of I is payload length -1. Ooh, hold on. Which probably means that this was off by 1. This was too conservative by 1. Yeah, because the max value of I is not 4, it's 4 minus 1. Yeah, so this was... I did this. And then I put a 4 here, and I was like, wait a second, that's not enough. But no, it is. Because I is never exactly equal to 4. Yes. I understand the code I'm writing. It's an hour into the stream and I still haven't solved my bug, as I predicted. As I predicted. This is fine, though. This is exactly right. Ooh, this is not exactly... What's happening here? Oh my god. Well, that's totally wrong, obviously. Yeah, this would make sense to do for text data, I think, kind of, but we're not dealing with text data anymore. Okay, sick. Alright, last thing we gotta do is subtract this number appropriately. This still probably isn't totally safe, is it? Like, I trust and believe that received bytes is actually going to be a uint64 at first here, but what about this subtraction that I'm about to do? Yeah, this is pretty yikes. Whatever. We'll do that for now. We'll do that for now. This, I think, is a more promising source of problems that I could fix. I absolutely want to print if something like this happens. Okay. Let's see how close am I to having working code. Not... Actually, I think I know what this is about. This totally makes sense. I need to update my prototypes. Okay, unmask payload data. Gets one of those. And I've forgotten what any of these functions are called. Parse WebSocket frame header. I'm not sure if you're the one that I modified. Unmask payload data is the one. It was you, yes. Very good. Try again. Okay, it's still mad. You return an int now. And actually, you should actually... Oh, well, yeah, here's a problem. You should go ahead and return 0 here. There we go. There we go. Very good. Okay. Definitely probably going to end the stream soon. What time is it, IRL? Yeah. Yeah, I want some time to myself, definitely. Had another long day at work today. partially because I had to have a meeting with my financial advisor, and that was most of the reason, actually. It was just a really gosh darn long meeting. Okay, let's see what happens. Let's see what my server does now. Broke out early? Yeah. Yeah. See? We're preventing all the seg faults now, for better or worse. And in theory, it should kind of just continue parsing. It's going to skip a lot of key events, probably, by doing this. Huh. Now, what's weird is I don't know if I'm actually getting continuation frames, or the random junk memory that I'm taking in is being interpreted as a continuation frame erroneously. Wow. Look at that. I sort of seem to have fixed... Do I get any, like, absurdly large game time values? I don't seem to. Wow, that's pretty epic. That's pretty epic. Okay, so one thing I'd like to do... That's actually huge. That's huge. That's great news. What I can do is like quadruple this. 4096. And that should quite possibly solve all of our issues. And make all the weirdness go away. That's my guess. My guess is that RACV does weird stuff when you don't have a big enough buffer to take in all the data. Well, maybe not weird. My guess is that it does the most intuitive thing that I think of, which is that it copies what data will fit, and then the rest is kind of just sitting there incomplete. And it trusts, it like expects the user to do some sort of paginated read thing, which I'm not doing currently. Yeah, that stands to reason. I don't know what exactly I'm gonna do with that. That's concerning a little bit. Yeah, I wonder how much I/O I can actually store there. I mean, I've got like a gigabyte, right, of memory. I could just use that. If that is so, let's try this out. Let's hope and pray that this actually solves all of our issues. I sent the data. I'm concerned. What happened? Oh. Okay. Blink and you miss it. Holy crap. Oh, we have more than 4096 worth of data. That's a lot of data. Holy crap. This is really promising, though. This is supremely promising. I still got a seg fault. Darn it. Darn it, I still got a seg fault. That's some shit. Run C line... Oh, run C, yes, of course. That's the bash script I'm using to run the program. Huh. The fact that I can still get a seg fault is pretty disappointing. I guess I prevented one here, but... Huh. Yeah. That's a problem I might need to worry about a little bit, right? Like if any random user can just send garbage data to my server and cause it to get a seg fault, that is a problem I will need to work out for sure. Faux show. Okay, let me do a little bit of math here. So if we recall, we're sending 600 batches of data, and each of these pieces of data, that's not what I want to look at actually, contain 14 bytes. 14 bytes times 600. 14 times 600 is 8,400. 8,400. So it actually makes perfect sense why we're getting in some sort of seg fault error. Perfectly sensible. Because my buffer is simply too small. Simply too small. What was that number again? 600 times 14. 8,400. 4096 times 2 is still too small. Let's do times 2 again. Let's try 16,384. Surely that will be large enough. 16 kilobytes. And hopefully that doesn't make it run out of stack space. I think it's got more than 16K of stack. I think that's right. It should have several megabytes of stack. Anyways, here we go. Sending the data. Sending the data. Oh my goodness, the printing. There we go. That is a big number. Also, isn't that more? That's more data processing than I was expecting. That's more bytes than I was expecting. I was expecting significantly less than that, but okay. Okay, whatever. Yeah, why is... I thought I did the math. Oh, the math I did is just the payload. Yeah, the math I did is just the payload. I should actually be able to calculate this. So it's 600 times not 14, but 14 plus the header. So and the key. So I think it's actually 6. I think it's 14 plus 6, which is 20. 20 times 600, which is 12,000, which is exactly how many bytes we received. Yes! Yes! We're programming. Yes. Yes, we know exactly how all of this works. Always, all the time. That's a lot of elapsed time. That's pretty yikes. That's a little bit concerning. So this is 5 seconds. 100,000 million. Okay, a million is a second. How many seconds, pray tell, is this? So if I take 18,054.9 divided by a million, we're at 0.018 of a second. So that's actually tenths, hundredths, thousandths. That's like 19 milliseconds of processing time. That's really slow, I feel like. Isn't that kind of slow? 19 milliseconds to process 600 to process 600 key events? That seems really slow. $19 milliseconds for 600 key events. What is up with that? $600. Well, in theory, if this is a significant part of the processing, by packing multiple key events into a single request, we will be avoiding this. So if this is a large part of the overhead, doing less of this will maybe help us out. I do worry, though. I definitely worry about the performance a bit now. Concerning. I'm so amazed that we made these changes and it didn't immediately break. That's pretty crazy. That's pretty hard to believe. Yeah. Well, this is pretty cool. I would say we haven't really solved it, but we put a band-aid on the thing that was causing us trouble. And in theory, next stream we should be able to get a spectator up and running. If not next stream, then within 2 streams. So that'll be cool. Okay. Well, as always, thank you so much for watching. Hope to see you again next time. Might be tomorrow, might not be. As always, you never really know with me. But, hey, until then,